Today's lesson, section 3.2a, we're talking about polynomial functions and their graphs. A polynomial function is of the form a sub n times x to the n power plus a sub n minus 1 times x to the n minus 1 power plus ... all the way down to a sub 1 times x to the first plus a sub 0. And so some terms you need to know for a general polynomial function is that the a sub n power, or term, or value, is the leading coefficient. The a sub 0 value is your constant term. All the numbers attached to the x values, so all the a's, are considered coefficients. The a sub n times x to the n power term is called the leading term. N is described as the degree of the polynomial, so it's always the highest power of all the terms that you have. If you have a polynomial with one term, that's a monomial. A polynomial of two terms is a binomial, and a polynomial of three terms is a trinomial. Okay? And there's examples over here to the right of what I'm talking about. Okay? Now polynomials have smooth and continuous graphs, so that means that when you graph them, no matter what they're doing, it's always a smooth transition from up to down and vice versa. It is never like the stock exchange where it goes up and down really fast, quick change of direction. So there's no points. There's also no open circles for a polynomial function. It's always continuous. Okay? So it always passes the vertical line test. The end behavior of a function is going to be what the graph eventually ends up heading to as x approaches infinity and negative infinity. Okay? It depends on the degree n and the leading coefficient of a sub n. So what I mean is, when you're looking at a graph, we're looking at where the arrows are going as you head to negative infinity and as you head to positive infinity. Okay? So in this case, because we're moving to negative infinity, it's going down to negative infinity, because eventually it's going to make it to the negatives. It's not going to ever come back. And then also, as you're moving to positive infinity, you're heading upwards, so you're heading to positive infinity. So this is an example of when your function is considered odd positive. And then the technical terms are underneath. So when x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity as well. So then odd negative would just be the opposite. Here's a picture of that. So as x heads to positive infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. So they're just going in the opposite directions because, kind of, if you think about it as negative, the negative part is kind of like the slope. So overall, you're going from left to right down. Now, there's a lot of stuff that goes on in between, but if you just look at the arrows and connect them, then they have a negative slope, per se, if you were to make a linear line. P of x is even and positive, so that's going to look like this, okay, where both x heading to positive infinity and negative infinity, f of x is heading to positive infinity in both directions. Okay? And then if p of x is even negative, that means when you graph this, you're heading to negative infinity as you're going to positive and negative infinity for x. Okay? So those are the different types. Okay? Positive just means like going upward fashion. Negative means it's going downward fashion. Odd usually means that your arrows are going in the opposite directions of each other. Even means that your arrows are going in the same direction. So parabola would be a great example of a even function because your arrows are always going in the same direction as you head to infinity and negative infinity for x. Another thing that we'd like to talk about is power functions. These are functions of the form f of x is equal to x to the n power, where n is an integer. Okay? Now there's some transformations that we would like to talk about. So inside, if you're subtracting a value c to x, that means you're moving to the right, so you're always going the opposite way. If you're adding c, you're moving to the left. If you're adding c to the entire function, that means you move it up. If you are subtracting c from the entire function, that means you move it down. If you are multiplying a negative power or negative value to x on the inside of your function, that means you're reflecting over the y-axis. If you're multiplying by a negative value to the entire function, that means you're reflecting over the x-axis. Okay? So here, one thing we would like to sketch is these power functions with the some transformations involved as well. And we want to be able to show those transformations. So here, if you have x to the fourth just as a parent function, remember that it kind of looks like a parabola. It just becomes, it's flat as you're in between, or flatter than an x squared function in between 0 and 1 and 0 and negative 1. But after you pass 1, it becomes steeper than a regular parabola just because of the power of 4. The reason why it's flatter in between is because of the fractions. When you do to the fourth power of like a half, it gets you 1/16 instead of, if you squared it, you get 1/4. So it becomes a smaller fraction than before. So it becomes closer to your x-axis as you do that. So here, if I'm going to graph x minus 2 to the fourth, I want to do both. So x to the fourth, and then I want to show x minus 2 to the fourth. So my parent function, I'm just going to use 3 points here. So there's my x to the fourth. Okay. Now remember, for the next one, for 2, it's got to make it to 16, so that's why it's pretty steep from 1 to 16. Then I want to be able to move it. So it says negative 2, so that means move it to the right 2. So now my vertex is there. And then that would be my graph. Okay, let's try another one. Here you have f of x is equal to negative 2 times x to the fifth plus 4. So an x to the fifth one is kind of like x cubed. It's just in between is negative 1 and 1. It's flatter or closer to your x-axis because it's doing the same thing as that x to the fourth is. But then it gets steeper as you move away from 1 and negative 1 on both sides. So if I'm showing transformations, I first want to start with x to the fifth, and then I want to move my way out, so negative 2 times, or negative 2x to the fifth, and then we want to do negative 2x to the fifth plus 4. Okay? So x to the fifth, you got 0, 0, and then you still got 1, 1, and then if you plugged in negative 1, you would get negative 1. Okay, but then if you went to 2, that would mean that you needed to get to 32. So okay, so now I want to be able to do negative 2. So that means I'm flipping them, but then I'm also multiplying by negative 2. So negative 1 times negative 2 gets me a positive 2. So I go all the way up here. 0 would still be 0. And then 1 would become negative 2. So then stretches it even more. So now that 32 that you're supposed to get to becomes 64 on both sides. So it stretches it even further vertically. And then now we want to be able to add 4 to that. Since it's on the outside and not to just the x, then that means it moves it up 4 values. So our middle of the graph, so that 0, 0, is going to be at 0, 4. And then we're going to have negative 1, 6. And then we have 1, 2. Okay, and there you go. There's your functions. The next thing I would like to talk about is a real zero of a polynomial. So here, if c is a zero of p of x, now let's talk about what a zero is. So if I have a polynomial function where it crosses the x-axis is called a zero. Okay, so that's there. So an x-intercept, a zero, a root. These are all words that are considered solutions to the polynomial that create or make the y value zero. Okay, so that's what they're kind of saying. So if c is a zero, then when x equals c, it is a solution that makes the equation equal to zero. So the y value equal to zero. And so then that also means that x minus c is a factor, which we'll use later for the most part. And then also c is an x-intercept of p of x, just like I said. So it crosses the x-axis. So here, if I am talking about x squared minus x minus 6, then let's say we factored this. So then that would give me x minus 3 times x plus 2, and I did that by factoring. Okay? So then that means that x minus 3 and x plus 2 are factors, because you can write them like the x minus c up here. And then also, that means x equals 3 and x equals negative 2 are zeros of this polynomial because they cross the x-axis at those points. Okay? The next thing would be the intermediate value theorem. Now this one's tricky just to talk about, and some kids get confused, so I'm going to try to do the best that I can to explain what this is visually. If I have a function, p of x, that's polynomial, and let's say I have two values for my x's, so a and b, and they both have opposite signs. So let's kind of picture this here. So I have a graph. Oh, let's do a better job there. Okay. Actually, let's make it more obvious. Like right there. Okay, so I have these two values, a and b. Well, I don't care if a is negative or b is negative. I care if p of a is negative or positive and p of b. So that means it's the y value when you plugged in those x values. Okay? So on our graph, looking at this right here, okay, obviously p of a is less than 0 because it's below the x-axis. Here, when we plugged in b, p of b gave us a positive number because it was above the x-axis. Okay, so that's what they're saying. They're opposite signs. So this is a positive value. This one's a negative value. So when they're opposite, and it doesn't matter if it ends up in that order. It can be positive then negative, or vice versa. Okay, so it doesn't matter what the order is for that. They're just saying that if you have one that's positive, one that's negative, then at least one value of c, so another x value, falls in between a and b, where it becomes an x-intercept. Okay? So this must be c right there, because it gets this 0. Okay? Or makes your polynomial equal to 0, because it's a 0 itself. So that's what they're trying to say in the intermediate value theorem, is if you can find values, because sometimes they're decimals for your x-intercepts, so they're not perfectly visible to you because they're not factors. Like, they're not factors of integers anyway. They could be like decimals or anything, things that are hard for us to find for the most part. And so if you can find that change from positive to negative, then that means you've crossed the x-axis, which means that there must be a 0 in between there. Okay? And so that's going to be something that you're going to need to find. So here, I want to be able to sketch a polynomial function, and then if I'm given p of x, and here they're all written as factors. Okay? So let's think about where your x values are. or your intercepts. So x would equal -2 here, it would equal 1, and it would equal 3. So on your graph, that's where we want to plot some of our points. So I got a 2, I got a 1, and I've got a 3. Okay. Now, looking at the leading term, if you multiplied all your x values together, you would get x cubed, right? So let's go back to thinking about end behavior again. So here, if you had x cubed, the power means that it's odd. Okay, so that's how you figure out if it's odd. And then the leading coefficient is how you figure out if it's positive or negative. So in this case, it's 1, so that means it's positive. So if it's odd positive, that means that it should have this kind of shape. Now, it doesn't matter what's going on in between, per se. It only matters, really, where your arrows go. So that's kind of the helpful part. So if I have this graph, let's use a different color here. So on the ends, so like from this last intercept, it should go up to positive infinity because of that picture that we drew. And then on the left side, the last one, -2, to the left of that, it should end up heading to negative infinity. Now from here, we just need to fill in the gaps. Now, because you're crossing the y-axis, to sketch this, I would like you to plug in x is 0, unless it's a x-intercept already given to you, just to figure out what that value is, so you can get some depth. Okay, so if I plug in 0 here, I get 2 times -1 times -3, and that gets you 6. So 1, 2, 3, 4. So there's a point right there. So now when I come up, let's try a better draw there. There we go. And so then now I need to fill in the gaps in between, so then I have a 2 there, so let's plug in 2. So that gets me 4 times 1 times -1. So that gets me -4 here. So okay, and there's my graph. There's my sketch. Okay. And the last thing I'd like to do is to use all your stuff. So your intermediate value theorem. Here you kind of need to factor as well to kind of put it into the same look as what we had previously. So if there's anything you can factor out, you want to. So for this t of x function, it looks like I have an x squared that I can take out, so I'm going to factor that out. So it gives me with -3x squared minus 5x plus 2. Okay, and then from there I want to be able to see if I can factor. So then the first terms would be 3. So then you have -3 and 1 as factors, or 3 and -1, whichever one, or 2 and 1. Okay? So let's see which ones work. So if I did -3 times 6 and 1 times 1, that'd give me -6 and 1. That would give me what I want, because I want a -5, right? So if I do -3 and 2 opposite of each other, and I do 1 and 1 for this one, so then let's multiply it back out. So I get -3x times 2 is -6x, and then 1 times 1 is positive 1x. So together that gives me -5x, which is what I want. So there's my factor. Okay. So here, now I want to be able to graph this. Now it'd help if I figured out what my x-intercepts were. So here you got x is equal to 0 from this, okay? Because x squared, if you set it equal to 0, square root it, it just gives you 0. For -3x plus 1, just set it equal to 0 if you're not sure. So here it gets me 1/3. And then over here I get x plus 2. So x equals -2. Okay, so I got my 3 values. So 1/3, 0, 1/3. It'll let me graph it. There you go. So then I get you -2. Also, looking at my end behavior, let's go back. There's my leading term. So it's going to be an even, because it's to the 4th power, and then it's negative because you have a -3 attached to the top. So even negative means that you're going to have a picture that where both arrows are heading down. Okay. Now the stuff in between will really be different depending on what you're doing. Okay. So here, that means I go up. Now because you got between 0 and 1/3, there's not going to be much change there. Okay, one thing I want to talk about when we get there, there's something special about that x squared. Okay, so you've got this end behavior, you've got this end behavior. So now let's plug in -1 just to see what happens for that value, see where it is. So I'm going to plug it into this first one. So -1 squared times -3 times -1 plus 1 plus 2. Okay, so then it gives me 3, that's 1, so 4, 1. Okay, so it looks like I get 4 for that one. So I've already got the y-intercept, so I'm going to not worry about that. Now here, I'm not going to have you plug in like 1/6 or anything, so don't worry about that, because it's probably not going to get too far away. But this one, I kind of want to talk about, because if you have a 0, and notice that it's x squared, okay, so there's actually two things there. There's an x equals 0 and another x equals 0 because of the square. So this is something that we'll talk about in the next video, but I just kind of want to touch on it because it happens here. Something called multiplicity. So when you have 2 or more of something, strange things happen to your graph and how they interact with the x-intercepts. So if you have an even amount of like zeros at the same spot, that means that you're going to come to the x-axis, it's going to touch, and it's going to head back in the same direction that it came from. Okay? If it's an odd one, then that means it's just going to pass through. It's just going to get like, it's going to level out before it crosses, and as you get more zeros at that same spot, it's going to continue to level out closer and closer to your x-axis, but only when you get really close to it. Okay, so here I have got 2 of them, so then that means when I come up and down, I'm going to touch x, but because, let's see if I can do that better. I'm going to touch, and because the next one's so close, it has to come back really quickly to get to the 0, just because of the proximity. If it was further away, we could find a value in between and then determine what our graph would look like from there. But here it shouldn't get too far away. Okay? Have fun.